Hey folks, this is a free response for the AP Stats test coming up, so let's give it a shot here. So a random sample of 150 sales at each of two used car dealerships notes the number of cars sold at various prices. So we got two dealerships, dealership A and B, and how many cars sold in the $5,000 range, 10,000, 15,000, 20,000, and I see we have the mean and standard deviation of each also. So is the observed difference in these means significant? Okay, this one is suggesting a two-sample t-test, okay, where is their observed means and their differences significant? So our null hypothesis is there's no change, that it's not significant, and our alternative hypothesis is that there is some change, that it doesn't equal, okay? Just it didn't say less than or greater than or more or less than. So this one's a two-tailed one because it's not equal right there. Okay, so we're going to be dealing with these guys right here. All right, so we're given that they're independent random samples. Okay, so that's what it says up here, random samples up here with very large n. Okay, with n is equal to 150 right here. So our t statistic is given by this formula right here, and that they give you these. You can these formulas are given to you on stapled pieces of paper, you guys. At least they were stapled. I don't know if they still are. So anyway, so this formula is the difference in your means, which is the 13,000 minus the 11,933. These numbers right here. And then over the square root of standard deviation of the first one squared over n1, 150, plus the standard deviation of the second one squared over n2. Okay, so you plug all those numbers in, and I get my t statistic is 2.133. Okay, so our degrees of freedom is you take the smaller of the two. Well, they're both equal to 150. Okay, so I'm going to use 149 because it's always n minus 1. Remember that, you guys. And since it's a two-tail, okay, and you look up, and they'll give you a chart for your t distribution, you guys, and you look up your t distribution under your degrees of freedom for 149. And you're looking for your t distribution, so I get that our p-values is going to be 0.017, okay? And then when I multiply both sides by 2, this is p over 2 because it's a two-tail right there, I get 0.034, which is 3.4%, which is less than 5. So in general, if it's less than 5, then we say it is significant, okay? Now my old textbook, you guys, the one I teach out of was printed in 1999, so it's old, you guys. It gives me it doesn't have degrees of freedom. It goes from degrees of freedom. Let's see, it goes to 50, 60, 80, and then 100, then 1,000. So I had to use the 100 one right there. So it just told me that the p over 2 value is somewhere between. So I just scroll up to the top of my chart right there. It's somewhere between the 1 and 2% right there. Okay, so then I multiply both sides by 2, and it's somewhere going to be between 2 and 4%, and that's somewhere between 2 and 4%. So depending on what T or P chart they give you on that, or T chart, sorry, then that'll tell you right there. So with a P value this small, sorry, this little thing's in the way, I'm at school. So the observed difference in the mean sales prices is significant because my P value is 3.4%. Okay, so that's a two-sample T statistics. Okay, for B, oh, I'm sorry, in your calculator, you guys, you can do this in your calculator, by the way. You can do almost all of this stuff in your calculator. You go to stats, scroll over to tests. You're doing a two-sample T test. Two-sample, that should be a small p, I guess, or maybe that's how the calculator did it. Then you input your stats, okay? No pooled on this, and then you calculate your t. So when you hit calculate, you get a t value of 2.1337, and your p value is going to be 0.0337, which is under 4%, which is under 5%, okay? All right, so here's B. Is the observed difference in proportions of cars for $20,000 significant? So I'm just dealing with this, and when they're talking about proportions, you guys, that's a two-sample Z proportion test, you guys. So we're going to do a two-sample proportion Z test. Again, we want to know is the proportions, my null hypothesis is that there's no change, that it equals 0. My alternative hypothesis is that there is change. So again, it's another two-tail right there. Is it significant? Is the difference significant? All right, so So here's my N1P1, and I'm sorry, I got a student coming in. She wants me to sign something. Here, let me see it right here quick.
I haven't done it yet.
Okay, we'll fill it out, honey, and then I'll do that for you. I'm doing this AP Stat video. Okay, so N1P1 is this number right here, 12, sorry. And then, so the complement of that is from 150, so if that's 12, this is 138. N2P2 is this 23 right here. Okay, so and then the complement of that is from 150 is 127. They're both, they're all four of those are greater than 10. Okay, tardy. There you go.
Oh, sorry.
Yeah.
Thank
All right.
you.
Welcome. So we can go ahead and proceed, you guys. So let's go ahead and the samples are given at random, and the population of all cars is certainly at least of all used cars, so is certainly at least 10 times as large as the sample. So we can go ahead and proceed with our calculations right here. Okay, it's random, you guys, and all of these, my N1P1 and my the complement of that, all these are all greater than 10. So we can go ahead and use our Z statistics. Okay, so instead of estimating your individual proportions, you guys, P1, P2 separately, you can pool the two samples and use the overall sample proportion to estimate the single population parameter. Okay, it's called the pooled sample. So if you guys were in my class, you guys, we briefly discussed this and then we ran out of time. So it's really easy, you guys. So your count successes are we're gonna add them together and divide it by the total right there. This is 150 and 150 right there. Okay, you'll see. All right, so here we go. So this is a two-sampled z-test, and so we're going to just plug it in. So here's my z-score formula right here. Again, they give this to you. So you see the word proportion, you guys, and you want to know what's is it significant with these numbers right here? It's going to be a two-proportion z-test. And here's my formula for two-proportion z-test. So I got to find the proportion 1, proportion 2, and then this is going to be from this purple guy right here. Okay, and then this is going to be 1 over 150, 1 over 150 right there. So we just plug them all in, you guys. So P1, P hat 1, you guys, is the 12 divided by 150 is 0.08. P2 hat is this 23 divided by 150, gets me that. Okay, and then so my P hat, this guy right here, I forgot to put my hat right here. So just my plain old P hat is here's my x1 plus x2 over n1 plus n2. Okay, it's this stuff right here. Okay, so I get 0.117. Now just plug it all in to get your z-score statistics right there. And then when I calculate that out, you guys, I get a z-score of negative 1.97. So you go on your z table and you look up for negative 1.97. Remember, this is a two-tail right here, so I get 0.024. So multiply both sides by 2 and I get that. And that's less than 5. So there's how you do it in your calculator also, you guys. That's less than 5, so that is also significant in the mean proportions of cars from $20,000. So the difference in them is significant. So here's our answer. So with the observed difference in means, with the means, are they statistically significant? We found out it was yes. So for the observed differences between the $20,000, we observed those were yes. So using the above results, what would each dealership emphasize in its stockholders? Okay, so dealership A is going to say it would emphasize the mean sales in prices, and dealership B would emphasize selling the higher proportion in prices. Okay, take care, you guys.